right. So, if you would all open to page 144, according to my good friend Sam, we can talk about those couple of questions. So, number 4, what was the, for B, what was the domain? No, B.
Oh, B.
1, 0, -1. Now, those are all the right numbers, Nick. You're absolutely right. But we put the lowest one first. Okay? So, he has all the right numbers, but you want to put the littlest one first, and you want to put those squiggly brackets around it. Now, why, if I have 4 points, do I only have 3 values in my domain? Josh? Yes, because one of the points repeats. The domain is simply the list of elements in that set. And since 0 repeats, it's still in the set just the one time. And then what is the range? -1, 0, 1. Now, there's a problem here. A great many of you guys, when you're faced with the domain and range listed like this, you get stuck in your head, and I didn't say this until we talked about domain and range in a bit. We know that the domains are graphed on the x-axis, yes? And the range is graphed on the y-axis, yes? But is this an x value that is a pair with this y value? No. You have to be careful for that. These are just a list. They are not pairs. Okay? When they are listed as domain and range, they are just values. When they are listed this way, they're pairs. Everybody cool? Okay. So what is the domain in C? Right. Squiggly brackets, 2, 4, 6, 8. In order, squiggly brackets. And the range? 3, 5, 7, 9. Now this one's weird again, because in this one, they do match up as pairs, don't they?
But it's a list.
Just because it happens to here, sometimes it won't. So don't assume it always does that, is the point I'm trying to make. Is everybody cool? All right. What changes on D? We add a graph. The graph is made of points, yes? Each point has an x and a y value, yes? Great. So we covered the first 3. Let's carry on. What's that guy? 0, -2. What's that guy? 1, 0. What's that guy? 2, 1. And what's that guy? 3, 1. So what is the domain? -3, -2, 0, 1, 2, 3. Squiggly brackets. And what's the range? -3, -2, -1, 0, 1, 2. Why are there 7 domain values but only 6 range values? Because one of them repeats. And these obviously don't make pairs, do they? Everybody cool? Everybody cool? Okay. 1, 2, 3, 4, 5, 6. Oh, there is 6 and 6. Which one was I talking about? Oh, it's later on. Never mind. I know where I'm going with that. So now, turn the page over, and something is going to slightly change. But there's a big blank spot first.
Wow.
That big blank spot is entitled the vertical line test. The vertical line test is very handy. It is something we can use on graphs. Please highlight graphs because it only works on graphs. Okay. I'll let you finish writing that down. And then I'll ask you this. What's the difference between a relation and a function? They both have inputs and outputs. James?
Function has one output.
Right. Function has one output for every input. Right? No matter what I say for an input, I get a different output every time. Everybody cool?
Yeah.
All right. In a relation, that's not necessarily the case. Okay? Everything with two sets is a relation. Special relations are functions. Okay? So we're going to talk about the difference here. So we've discussed the difference. A relation has an input and output. A function has one input equals one output. And there's no repeating on the outputs. And here is what they look like on a graph. A relation would look like this. There's my graph, right? X and Y. A relation is anything on the graph. Okay? Every dot on that red line has an X and a Y, yes? If I say go to X0, what's Y? You go to X0, there's the Y. Is everybody cool? So X's and Y's are related right there. Yeah? Now, come over here to a function. And it's very similar, yes? Every point on that red line has an X and a Y, right? Now here's the difference. If I take a vertical line, see my black vertical line? And I move that along my graph, what happens right there? That black line at that X value hits the red line how many times? 3 times, which means for that X input, I have 3 outputs. Is that allowed? Yeah. It is if it's only a relation. So that guy's a relation. Does everybody see why? Now, if I take that same vertical line and I move it along the function, which I can't do because, of course, my computer doesn't work because it's garbage. Yeah, I do.
$5,000.
At least MacBooks work. And I slide this along. How many times does it hit the red line? It's always only once, yes? So for every one of these X inputs, there's only one Y output. Is everybody cool? And that's why it only works on graphs. Because you can slide it along the graph. Everybody good? Okay, so let's look. Now I've got a bunch of graphs here for you, yes? So we've already done it with real life. We did it with hours and pay. We did it with ordered pairs, 1, 0, 0, 1, right? Now we're going to look at it with graphs. So this is graphed, yes? It's a little hard to see, so I'm just going to make the dots on mine a little bit bigger. Because it might be a little hard. Well, it's not too bad when it's magnified up there. There's one there, 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 there. And if I take my vertical line and I slide it, and I slide that vertical line, anyways, you should notice that right here, what happens? It hits 2. And right there, what happens? It hits 2. So is this a function or a relation? It's a relation. Why? Because at x equals -1 and x equals +1, there are multiple outputs. Everybody understand? Everybody cool? All right. So now, the next part of this question is I want you to tell me the domain and range. I'm going to do the domains in blue, the ranges in red. What is my domain here? It's every x value, right? So what is the first x value we see? Then what? Then what? Then what? Then what? Then what? Then what? Oops, squiggly bracket. Everybody cool? Everybody good? Okay. What's the range? Where do I start? The highest or the lowest? Lowest. What is it? -2. Now stop for a sec. Is that an ordered pair? No, because -3 goes with the 0, doesn't it? So this is not going to be a situation where this works out in pairs. What's next? -1. What's next? What's next? What's next? What's next? 3. And what do you notice? There's only 6 range values and 7 domain values. Is that okay? Yes. Everybody cool? Everybody good? Everybody understands how this works? Okay. Now, you guys are smart kids. If you understand it with dots and points on the graph, can you translate that to lines on the graph? Yes, because what is a line? It's just an infinite amount of points, isn't it? So let's go to the next question, which shows a line. Now, when I had dots, why did I have to write my domain this way? Because my domain are my x values, yes? And I have an x value right there at -3, yes? Because I had an output right there of 0, yeah? My next x value is -2, right? Are there any outputs between them? No. So that is why I have to write my domain this way, because there are no inputs between -3 and -2. Is everybody cool with that? Now, what is different about B? Here I am at -3. Here is -2. Are there inputs all the way along there? Yes. Do those inputs continue? Out to where? All the way out to there, yes? So now, is it possible for me to write my domain this way? How? I need to show every single input from -3 to +3. How many are there? It's infinite, isn't it? Because just between -3 and -2 is infinity, isn't it? 0.000000001. Then 0.2. 0.3. Could we write this here? No. So how can we write it? You've already seen this in the hours question. Right. What's my lowest value? -3, right? Squiggly brackets, of course. Right? All my x values, are they bigger or smaller than -3? Bigger. So -3 is less than or equal to all my x values, yes? But my x values have to be less than or equal to what? +3. Squiggly brackets. Is everybody cool? Everyone see how that works? Okay. Which part is confusing? Are you comfortable with this part? Why? When we list them?
Yes.
Because it's dots, right?
Yes.
There is no x value on this graph between here and here, is there? So I have -3 as my first x value, -2 is my next x value, yes? You cool? Okay, on this line, on the second graph, and of course my computer sucks. On the second graph, my first x value is -3, yes?
Yes.
And as I go on, you can see that that point's got an x value, right? And that one, right? And that one, right? And that one, right? And that one, right? And there's an infinite amount of x values there, isn't there? Because I can chop that up into as tiny pieces as I want, yes? So that is why I have to write it. My x values are everything between -3 and +3, including every single decimal. Do you understand? You got it now, Nick? Okay. Excuse me. This is what we call set notation. And it actually even gets more complicated than that. For grade 10, though, we're going to leave it like that. But math guys are lazy, aren't they? Math guys don't want to write all that out, so they invented a shorter way to write it. And this is how they write it.
Isn't that smarter though?
They put a square bracket, -3. Then they put the other end of it with a square bracket.
Wow.
And that is called interval notation.
When we do this from now on.
Just wait. No, because interval notation has a problem. You can only use interval notation when you have a line. You can't use interval notation if it's just dots. Okay? Brianna.
So like you could use it for that one, but like you couldn't use it for...
Couldn't use it for A.
Okay.
Can't use it for A because there's no interval, right? There's no values there. So I can't say it's 3 to 3 because all of these are blanks. Picking up what I'm putting down? All right. Now you guys are smart kids. What then is the range? Where do I go to find range? I go to which axis for the range? The y's. What's the lowest y value I have? -2. And is there a y value all the way up here? Till when? +3. So it must be -2 less than or equal to what? Y, which is less than or equal to what? 3. How would I write that in interval notation?
Square bracket, -2, comma, 3.
Square bracket. Can everybody do the easy two? Okay, now listen to me. The next two graphs are going to look different. Do you think that I have put you in a position to not be able to do them? No. Of course I haven't. You're going to use your brains and you're going to look at that one and you're going to think not what bothers you about it. You're going to think what you already know about it. What do you already know about this part of it, where there's a line? This part. Oops, I didn't want that to be that thick. What do you already know about that part? If that was the only part of the graph, could you tell me the domain and range? Great, let's do that. What is the domain of that first part? Look very closely because I have made a little tiny change to see if I could trip you up. It is indeed negative 30.
Wait, you can't use those.
10, 20, 30. I can still use those. Is everybody cool with that? Now, so I'm going to go, and negative 30 is the lowest value I can have, yeah? So it's less than or equal to what? X. But X has to be less than or equal to what? It stops at negative 10. Now look carefully. Does this look like that? No, what's different about it? What's different about that point, the way it's drawn, and that point? One's a circle, one's a dot, yeah? Who remembers the 9th grade, the last time you saw greater than and less than?
Oh, is that the one where you like switch it if it's like a whole line?
X is greater than 7. Put that on the line. Circle 7, and it's greater. X is greater than or equal to 7. What do I got to do? Color it in. So, what do you think is happening here in the 10th grade? That one's colored in, so do I include it? Yes. So it gets the equal sign. Is that one colored in?
No.
So is it included?
No.
So does it get the equal sign? No. Everybody cool? Now use your brains. Put it in interval notation. Well, I know that if that one's included, I know it's a square bracket. And I know I'm going up to negative 10. But this one's not included. So can I use a square bracket? No. So we use a regular bracket.
Whoa, what? Bruh.
That's what's confusing people. Unbelievable. It's yes or no. Is the dot included? No. So it gets a round bracket. Is this dot included? So it gets a square bracket. It's not that complicated, guys. All right. Now you guys are smart kids. What's the range of this part of the graph? Negative 20. Is negative 20 included? How do you know? Because it's got a closed dot. So it's less than or equal to y, which is less than or equal to, wait. I'm on the y's right now.
So it's
Less than
zero.
0. Okay, which part, Ethan?
Oh, this one.
Did you understand it here? Where we went down to negative 1, 2? Negative 20 up to 0. Yes? And on the range, we have negative 30 up to negative 10. Yes? Now, what is the interval value here? Square bracket, negative 20. Regular bracket. It's everybody cool. Now, the domain is all the elements in the set. Yes? Everyone agree? Okay. Have I covered all of the elements in the set? No, because what's happening over here? I got another whole line, don't I? What is this line's domain? What does it start at? 0. Is 0 included? How do you know? Because the filled in dot. And it goes up to what? 30. Is 30 included? How do you know? Not colored in. So it's just a less than 30 squiggly bracket. Yes? Now, you guys are smart kids. I have 2 sets of range, or domain, right?
You can add them.
Yes. There is a symbol to show that those 2 are part of the same graph. It's a big U.
Wow.
Stands for union. If they weren't part of the same graph, there's a different symbol, but we don't worry about that in grade 10.
No, so I look at the.
What's the first dot?
No,
We're doing domain. We're doing domain only, Riley. It's frustrating, isn't it?
X. Go here. This be 0. This is 10.
Okay, no. Sam, you guys are making a mistake that kids make because you're not teachers, right? Go back a step. Do you understand the first part?
Yeah.
So, how did you know we started at negative 30? Because you're over here at negative 30. Where does this line start? Right there. We're going this way. We're doing our domains. That's why it's D and that's why it's blue. How do I do this one in interval notation?
Bracket.
What kind?
Square.
Square.
0.
And what goes in the middle? A U. Now do the same thing for the range. What's the lowest one there?
10.
10. Does it hit 10?
No.
No. How do you know that? Because it's an open dot. So is it less than 10 or less than or equal to 10? Less than 10. There we go. And y has to be less than. Does it get up to 30? Yes, because that's a closed dot. So that one gets the equal sign. How do I write? And then what goes here? A U. What is this in interval notation? Normal bracket. Normal bracket, 10. 30 square. And what goes here? No, not an actual U. This symbol. It's not actually a U. Because the symbol, if they aren't part of the same thing, is that. All right. Is everybody cool? All right. Now, letter D has everything that we have learned in the entire lesson in it. Okay? So we're going to go real slow through it. We're going to start with our domains. Where do our domains live? On the X or the Y axis? On the X. So we're only going to look at the X axis. How far to the left must we go? No, look again. -6. Thank you, Josh. Now, is that -6 included? No. So squiggly bracket, -6, less than, no equals to, right? Now, let's go along here. Does it go all the way to 3?
No.
Yes, it does. 3 is included. Now, what? -3, yeah. What happens to just the X values? Do they carry on? Yes. Up to here. And then do they carry on again? Up to where? To there. Right. Is the +6 included? Yes. So what symbol goes here? Equal to 6. Squiggly brackets. Can I write that as an interval? What is it? regular bracket, negative 6,
And then square.
square bracket. Is everybody good? Okay. Now let's look at the range. What's my lowest range value?
It would be -3.
No.
What?
Where are the ranges? On the y-axis. Where's the only values I have on the y-axis? 3, right?
Oh, I said negative.
3. Now, look closely. Is there any range values there? No. What's the next y value that I have? 6. What's the next y value that I have? 9. Now, I colored in any of the axis? No. So can I do an interval? No. I cannot do an interval notation here because they are in single values, just like up here. Okay? What?
They have a single output.
The outputs are singular. They are not it is not a bunch of numbers. It is only 3, 6, or 9. There are no decimals. Whereas on the x value, I can have all of these decimals. Understand? Now, here comes the $1 million question. Is this a function? Function?
Yeah.
Function? 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 You sure?
Oh, wait. Yeah. One's colored in, one doesn't.
One's colored in, one isn't. That point exists because it's colored. Does that point?
No.
No. What about 1/1,000,000th of a millimeter to the right of that point? Does it exist? Yes, but that point itself doesn't. Because one's clear and one's colored, that is still a function. What if I did this?
That is.
Now what is it? A relation. Is everybody good? Yes? Everyone is good? Okay, I want to make a couple of little tricky moves here. Okay? So in E, if I have a graph that goes like this, -1, -2, -3, and it's colored in, and the graph goes, and there's an arrow there. What does that arrow mean? Keeps going where?
Down.
Downwards and
Across.
and to the right. For how long? Ever. So, my range, or my domain, which is in blue, what's the lowest range domain value I have? Blue, please.
Oh, wait, negative.
My day would be a lot less stressful if I didn't have this technology to make my life easier. I would love to use the whiteboard, Josh, but when I see how little you guys write your notes, when I write 90% of them for you, I can't imagine how little would get written down if I used the whiteboard. Right? I would love to say, well, that's your problem, but that's not the way the world works, is it? Oh, we're sorry. OneNote is cleaning up from the last time it was open because it was such a mess. What is my lowest D value? Negative 3, right? Squiggly bracket, negative 3, less than or equal to, it's a closed dot, x. Where is this arrow going to end? Infinity.
So
Right?
less than or equal to.
So, will I ever equal infinity? No. So it is less than infinity. Squiggly bracket. Now this is where it gets a little bit tricky. There's another way to write this. X is greater than or equal to negative 3, because that covers everything. There's no end, right? Everybody with me? Now, here's where it gets tricky again. Can I write this as an interval? Because would I color along here? For how long? Forever. What's the lowest value? Did I hit negative 3? So what bracket does it get? Negative 3. What do I go up to? Infinity. Will I hit it? So what bracket does it get? Done. Now, what about range?
Negative infinity.
What is my lowest y value?
Negative infinity.
Negative infinity, because I start at the negative. Will I ever hit it? No.
So it's greater than.
No, it's still less than. Y. Less than or equal to what?
3.
3. Everybody cool? How else can I write that? Y must be what?
Regular bracket.
No, not interval yet. This one, because there's an infinity. We can write it this way and another way. What are all my y values on this graph going to be? Greater than or less than 3? Less than or equal to 3, because they all go down from there. Agreed? I would start coloring there, and I would draw down for how long? Ever. Everybody good? What is my interval here? What's my lowest possible y value? Negative infinity. Will I hit it? Negative infinity. To what? Will I hit 3? Yes. Does everybody understand? What if that arrow flipped around and went up? Then it would be positive infinity, right? And the y would be greater than 3. Picking up what I'm putting down? All right, now listen to me. The next couple of pages, there's 2 pages of textbook work. The answers are there. As always, there is no point in me checking this over because the answers are there. You're either going to do one of 2 things. You're going to do all the work and have all the right answers, in which case, awesome. Or you're going to copy out all the right answers and not really know what you're doing, but I'm going to think, oh, you got them right. Do some of this work. If you do the first one and you get it perfectly, you do the second one and you get it perfectly, do you figure you got it? Yeah. Maybe. You might want to try the last one. All right? You don't have to do all of it. But if you do none of it, it is your problem. Got it? Now, what I am going to be looking for is when you get up to this page that has graphs. I want you to do these 2 pages, which are 149 and 150. I want you to do these, half of them in set, half of them in interval. You choose which ones you do for which. Now there's a couple of ones I want to stress here. This arrow, this one in number 3, goes flat. It continues to the right, but it does not go down. Number 5 is going up ever so slightly. So it continues to the right and up. Does everybody understand? Okay? When does this have to be done?
Tomorrow.
No. Because what's happening tomorrow? Cumulative exam. So when does this need to be done? Monday.
Whenever we have school. Yeah. That's not Wednesday.
I'm so happy. By the way, Mr. Myers, are you booked for parent teacher?
I have lots of space.
Okay. Why are you answering the last question?
Okay? Now, I have free time. Josh, are you writing this down? The free time I have. On Thursday, if your parents wish to visit with me, these are the times that are free. You can tell them. I am free from 10:15 to 11:15 as of now. I may get emails tomorrow booking that time up. I am free from 11:30 to 12:15. I'm going to eat lunch between 12:30 and 1. And then I am free from 1:45 to, I will probably stay a little late to help parents out. I'm going to say 3. If I still have a parent, if somebody emails me and says, I can't possibly get there before 3:15, I'll stay. Okay? I'm aware of that. All right? That is the time I have free. Also, I have a little bit of time, like 8:45 to 9:15. That is what is available now. I am assuming most parents will want to speak to me for 10 to 15 minutes. That is what I have based this on. If a parent needs to speak longer and there's no one lined up, I will obviously speak longer with them. I'm not going to sit here with a stopwatch for 14:57, 14:58, 14:59, 50 minutes. Get out the door. Okay? As you are all aware, that is not the way I run my business. If somebody leaves after 3 minutes, they come in and I say, your kid's doing awesome, keep it up, does all their homework, does great on tests. That takes 2 minutes, and your parent is next in line. They do not have to wait for the 15 minutes while I sit in here with my, no, sorry, it's not time yet. Okay? Everybody understand? Jack.
We're not supposed to come to this, right?
You can if you wish.
But we don't need to.
No, of course not. But I will warn you, if you come to this, I will be speaking to your parent as if you are not in the room. Okay? No. But I will be talking to your parent about you. Okay? If you feel you are not ready for direct criticism of you, with you in the room, do not come. If you wish to come to defend yourself from said criticism, by all means do. All right? I will be treating you exactly as I treat you here. If you screw around in my class, I let you know about it. If your mom, or dad, grandma, grandpa, auntie, uncle, pet rock, whoever is in charge of you is here, I will tell them exactly what I tell you in class. So if you are guilty of constantly Snapchatting, I will be telling your mother, father, grandma, grandpa, auntie, uncle, pet rock, whomever, that your child cannot keep his or her hands off his or her phone. Okay? To which most parents respond, well, why don't you take it away? And I say, because every time I take a phone away from a kid, they go home and they tell their parents that I took their phone away and I get in trouble from their parents. Which is also true. All right? Brianna. Well, I stopped being paid at 2:30. So if you had a job at McDonald's and you stopped getting paid at 6 o'clock, would you stay around frying burgers till 8? No. I will stay as late as I need to stay. I'm sorry? Well, that's Miss Johnson. I'm not Miss Johnson. I am old and I am a man. She is young, a woman, and teaches English. I will be staying at least until 3 o'clock. At least. If I look out the door at 3 o'clock and I see 6 sets of parents, I will probably stay later because I believe as a parent that I want to speak to my kid's teacher. However, also by the same token, I am aware that teachers have lives outside of school and need to get to them as well. So I would not try to schedule a meeting with the teacher at 8:15 in the evening. Right? I would try to make it as close to school hours as I could. And I would ask, which is exactly what I've had to do. My son's parent-teacher interviews are on November 30th, which is a school day. Their school is staying until 4 o'clock. So I have 3:24, 3:36, and 3:48 with the three of my kids' teachers that I feel I need to see. I will not be visiting his phys ed teacher or his graphic arts teacher. Okay? And I'm not going to take time off work here to go do that. Because I have a job here. Huh? The TOCs cost money. They aren't free. If I take a day off, I still get my salary because it costs me a sick day, but then they also have to pay the TOC. So if I take a day off for nothing, that costs the district extra money. I can get there by 3:48 or 3:24. I just have to leave right away after school. So on that day, November 30th, I will not be here for even 1 second after school to help you guys because I will be going and dealing with my own personal child. Any questions? And again, if your parents desperately wish to talk to me and they cannot get time off work in any way to get here in time, please tell them to email me and I will sort something out. At the very least, I will get a phone number from them and I will call them after hours and speak personally with them because you cannot have an interview about a kid over email. You're just the one I'm looking at. Right? You can't have an interview about you guys over email. It's impossible. You guys know how hard it is to do anything by text. Right? Because whenever you read a text, you put in your own tone to it. Right? So if I say, your kid never pays attention in class in a text or in an email, that sounds significantly different than, your kid never really pays attention in class. They're different. Right? So I don't like doing that by email. I will at the very least call them if they can't possibly get in to see me. If they desire to see me.
You can FaceTime.
I could. That is essentially the same as calling. Any questions? All right, you guys got work to do. Get doing it. Your cumulative tomorrow is on those 4 things. All right? They are on exponents, radicals, square root of 48, simplify it. No. Expansion, x plus 3, x squared minus 7x minus 3. Expansion. And factoring, x squared plus 7x plus 12, x plus 3, x plus 4. That stuff. That is tomorrow. Okay? You have your entire book to read through. And if you wish, you can come in at lunch tomorrow, or you can use some time right now to look at your last 2 tests. But they can't leave the room. I have your last test. Okay? So those are your 2 choices right now. You can work on 147 and 150, or you can prepare for your cumulative tomorrow. How do you prepare for your cumulative tomorrow? You read in your notebook, or you look at your old tests, both of which have been gone over by me, both of which times I told you you should make sure you put the correct answers on here, so when you study from it later, it will be helpful. Okay? Go!